Hey YouTube, I'm about to make some modifications to my generator here, and I thought that it would be fun to show you what it currently does. Now, unfortunately, it's a little bit less impressive with this part removed from the middle. It allows air to interact with these rods a lot more, and I lose a lot of charge through it. But, I mean, that was what was in the last video anyways, so, I mean, you guys saw what it could do. Now, I've got my, my wires here hooked up back off of my regular taps, and we're going to make some sparks with that. Set up in this configuration, essentially what's going on with this generator is it's basically a Toepler-Holtz, because I have an inductor plate that's powered over here. In the center, I have the tap that I'm drawing my power off of, and over here, just before leaving my inductor plate, I have my neutralizer. The setup is mirrored on the other side, and rather than using flat sectors, I chose to go for more of a die rod style configuration, but I chose to use pipes instead, and I didn't realize it at the time that I chose to use pipes, but it's actually an incredibly good idea, and it multiplied the current that I'm getting out of the machine by way more than just the added surface area from the inside of the bar, because what ends up happening is I get a Faraday ice pail effect happening inside of this tube. So I'm trying to ionize this tube, and because of the Faraday ice pail effect, that just becomes like phenomenally easy. And once I get up to the voltage ranges where I'm like at like 30,000 volts, that kind of thing, like the effects that's happening on these tubes is very significant. Normally, an electrostatic generator does not have charge carriers that use the Faraday ice pail effect. I do, and it makes a light years difference in the output. It was a happy mistake, but I'm glad I made it. Because check out what I can do with my fingers at a very, very low speed. Like I come over here and I just turn it. Like this is not difficult. This is not difficult at all. This is nothing. This is one hand. Hang on, just to prove it's still one hand. So check it out. Now we'll go two hands. Every time the sparking frequency stops, what's going on is I'm getting arcing on the inside of the motor. Saps out the energy from my inductor plates, and basically ruins the effect that's happening here. Now that's a spark distance of about 1 centimeter. I measured it just earlier. But anyway, I figured I'd film that and show it to you guys before I make my modification, so that if I decide to take any videos of the modification, you guys can kind of get a sense of the difference in the effect and the difference at which charge will build up. Also kind of give myself something to refer back to. But it's so phenomenally easy to accumulate some charge this way. And it makes such a high voltage for something so simple. I find these electrostatic machines to be absolutely fascinating, and it's my opinion. I know that there's a bunch of engineers out there that are going to disagree with me, and that's fine. But I'm not really looking to start a flame war or have any fights about it. But it is my opinion that these electrostatic machines function on the terms of a coefficient of performance when they are properly designed and situated in the correct environment. Look at this. It's still sparking there. How hard is it for this machine to turn? You can still hear the sparks going off. How hard is that? You can just imagine how difficult it isn't to turn this machine. It really seriously does not take a very powerful motor to turn this. And you know what? Maybe I'll prove that for you right now. So I got this fan motor here, and it's not a terribly powerful motor. I'll get this hooked up and screwed on, and you guys will get to see, like, it really seriously doesn't take very much in the way of physical force to drive this thing. I'm really impressed. It's light years and beyond easy to turn in comparison to the Wimshurst machine that I had put together earlier. I had tried to do it with contra-rotating gears, and I found that I'm going to have to go grab a different Allen key here. And I found that the Wimshurst was, I mean, it was difficult to spin. Because what ends up happening is, as you start building up the power on the machine itself starts to fight you, because the two contra-rotating discs, which need to be very close to each other, start like pulling on each other. And that pulling that they do draws the two discs into each other, and you can get a lot of friction. I mean, I found as well, because I mean, I didn't have bearings when I made mine, so they were just running loose on the clothes hanger wire that I had clipped for the thing to go with. And it really didn't work out well for that. Okay, so I'm going to have to bring this a little closer to the side over here to get close to the power plug. Now, for you guys, what I just stuck on here is this motor here. So you can see 120 volts AC, 0.4 amp. So this is a 48 watt fan motor. This drive shaft is crooked and the bearings are shot. So be kind. It's not going to spin it very hard, but it will spin it. Hold the bottom here with my foot while I attach the wire. Ah, shit. Oh, that worked out better actually. Check this out. It fell off because I let go of the motor, so I put the end back on just to give it a bit of a twist, and it's spinning even faster now. Get that back into position there a little bit. So there you go. So 48 watt motor. Awesome. Now that I know this, I'm going to plan out a different fitting. One that gives this the end of this motor a little bit more freedom to rotate. And I'll just use this. I even got 3 connections off this meter, so I could slow, or this motor here, so I could slow it down. Check out what's going on inside of this motor, or this generator, I should say. See all that blue flashing in there? That's all wasted energy. This is all stuff I'm going to be fixing. There it is. You can see it in the center. So, that was a pleasant surprise. I wasn't expecting that. Let's see if I can get this off. I'm going to have to turn this off so I can turn this motor off safely. Or put you down. But I've done about all I'm going to do for now anyway, so I think I'll turn you guys off. Until next time, YouTube, see you later.